Hello everyone, myself Helimitta, working as an assistant professor in computer engineering department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Our subject is computer network. Our unit is 4, network layer. So today our topic is routing protocol. So in routing protocol we have a two parts, that is interdomain and intradomain. Okay, in interdomain we have a path vector. So protocol is BGP. Okay, in intradomain we have a distance vector, that is RIP, and in the intradomain another is link state, that is OSPF. Okay, so in today's lecture we will see OSPF routing protocols. Okay. So OSPF stands for Open Shortest Path First. OSPF is a link state routing protocol that I have explained here. Link state routing protocol. Okay. OSPF is based on the distributed map concept. All nodes have a copy of the network map which is regularly updated. Okay. Each node contains a routing directory database. Okay, this database contains information about the router's interface that are operable, as well as status information about adjacent router. The router have a left node and right node. Okay, so they are their adjacent routers. This information is periodically broadcast to all routers in the same domain. Okay, so router must be in the same domain. So all the information about the router is periodically broadcast to all other routers. The OSPF computes the shortest path to the other routers. Okay, so we have a multiple path between source to destination. So OSPF always computes the shortest path to the destination. OSPF protocol is now widely used as a interior router protocols in TCP/IP networks. Okay, OSPF computes a route through the internet that incurs the least based on a user configurable matrix of the cost. The user can configure the cost to express a function of delay, data rate, or other factors. So OSPF is able to equalize the loads over multiple equal cost paths. So we have a multiple path, from that they compute the shortest path. OSPF is classified as an internal gateway protocol, IGP, because it supports routing within one autonomous system only. Okay, so we have a one autonomous system, and OSPF is supports routing within that one autonomous system only. The exchange of routing information between autonomous systems is the responsibility of another protocol, an external gateway, that is EGP. OSPF can support one or many networks. So remember this, OSPF is supports the routing within one autonomous system only. Okay. So features of OSPF. First, OSPF supports multiple circuit load balancing because it can store multiple routes to the destination. So we have a multiple routes between source and destination, and it will select the shortest path. Okay, so it will store the multiple routes to the destination. OSPF can converge very quickly to network topology change. Okay, so if network topology is changed, then they take action very quickly. OSPF supports multiple matrix loops. OSPF is not susceptible to routing loops. Okay, OSPF supports for variable length subnetting by including the subnet mask in the routing message. So see here, OSPF introduced a two-level hierarchy for improving scalability. Okay, it allows an AS or autonomous system to be participated into several groups called area. Okay, so see here we have a different groups. Okay, they are represented by the circle. Okay, so that are the area. Okay, different groups. Okay, that are interconnected by a central backbone area shown in the figure. Okay, so these all are connected with central backbone. Okay, so these all are they are divided into circles. Okay, so they are the different area, and it is known as a several different groups. Okay, as area is identified by a 32-bit numbers known as a area ID. Okay, so they have a area ID. So 193.0.02 is the area ID for this area. Okay, so this is the 193.0.0.1. So they have a area ID. The backbone's area is identified with area ID 193.0.0.0. Okay, so backbone is at center. Okay, 193.0.0.0. Okay, they have another three area, that is 1, 2 and 3. So this is the backbone. Okay, backbone area. The information from other area is summarized via area border router that have connection to multiple areas. OSPF use the 4 type of routers. Okay, an internal router is a router with all its link connected to the network within the same area. So area must be same. Okay, so internal router is a router with all its link connected to each other. Okay, an area border router is the router that has its link connected to the more than one area. Here we in internal router we have a same area. Second, we have a border router in which we have a more than one area. Okay, so link is connected between more than one area. A backbone router is a router that has its link connected to the backbone. Okay, so in this figure we have a this is the backbone area. Okay, an autonomous system boundary router ASBR is a router that has its link connected to another autonomous system. Okay, so when one autonomous system is connected with another autonomous system, then the autonomous system boundary router is used. Okay, so there are 4 types of router. First is internal router, second is border router, third is backbone router, and fourth is autonomous system boundary router that OSPF will use. So as shown in the figure, router R1, R2 and R7 are internal router. Okay, so R1, R2 and R7 are internal router as they are in the same area. Okay, so for this area we have a R1 and R2. For this area we have a R7. So they are the internal routers. Okay, router R3, R6 and R8. Okay, so 3, 6 and R3, R6 and R8, they are at the boundary. Okay, so they are the border routers. Okay, so as name suggests, they are at the border of the area. So R3 is at a border here, R8 is over here, R6 is over here. So they are known as a border router. Okay, R3, R4, R5, R6 and R8 are the backbone routers. So 3, 4, 5, 6 and 8. So 3, 4, 5, 6 and all. They all are, okay, they all are in between and at border. They all are known as a backbone router. And R4 is an, see here, this R4 it is at a autonomous system. Okay, so R4 is known as a ASBR. A hello protocol allows neighbors to be discovered automatically. Okay, 2 routers are said to be neighbors if they have an interface to common network. The OSPF protocol runs directly over IP using IP protocol 89. Okay, so hello protocol is allows 2 neighbors to discover automatically. Okay, 2 routers are said to be neighbor if they have a interface to a common network. So if they have a common network, then they are the neighbors. Okay, so OSPF operation consists of the following stage. OSPF sends the hello message for discovering the neighbors, and designated routers are elected in multi-access network. So see here, OSPF first send hello message to discovering its neighbor. Okay, so neighbor means they have a common network. Okay, so OSPF first send the hello message. Adjacencies are established and link state data bases are synchronized. Okay, so adjacencies are established and link states are synchronized. Link state advertisement are exchanged by adjacent routers to allow topological database to be maintained and to advise inter-area and inter-AS routers. The routers use the information in the database to generate routing table. So routing table is generated over here. Okay, so these are the operations consist by the OSPF operation consists of following stage. So these are the 3 stage, okay, for OSPF operations. So see here we have a header format. So the header format of OSPF is shown in the figure. So we have a 32-bit format, so 0 to 31. So first is version, then type, then packet length, then router ID, then we have a area ID, then we have a checksum, authentication type, authentication and data. So remember this diagram, OSPF header format. Okay, so first is version. OSPF header analysis is given below. So for version, these fields specify the protocol version. Okay, type, this field indicates the message as one of the following type. We have a multiple type of message. Okay, so first is a hello message, second is database description message, next is link state message, link state update message, and link state acknowledgement. Okay, so from that they are over here types. Okay, so these all are the types. Next is packet length. Okay, these fields specify the length of the OSPF packet in a bytes, okay, including the OSPF header. So OSPF have a packet, okay, in the byte, and they have a header also. Router ID, it identifies the sending router. Okay, this field is typically set to the IP address of one of its interface. So IP address is set over here, so it is the router ID. Area ID, this field identifies the area this packet belongs to. Okay, so from which area this packet is transmitted. Next is checksum. The checksum field is used to detect error in the packet. As I was explaining the earlier, checksum is always used to detect the error. Checksum is performed on the entire packets. Okay. Authentication type. It identifies the authentication type they are using. And next is authentication. This field includes a value from the authentication type. So these are the field of OSPF header format. Thank you.